go. Our objective for today, I can identify arithmetic and geometric sequences. Let's read together. 1, 2, 3. I can identify arithmetic and geometric sequences. So this is the first lesson that's going to prep us for Algebra 2 and geometry. This is basically the very first lesson that it's a little bit out of the scope of algebra, okay, because it's prepping us already for what's coming up next. However, one thing that you probably asked yourself in regards to the homework, you saw, what was the first page on the homework? 237. The other one was 7 what? 35. Notice that they're really far apart. The book introduced arithmetic sequences at the beginning of the year, and they introduced geometric sequences right now in chapter 11. I wanted to introduce both of them together so you guys can notice the difference from one to the other and actually see the connection. Everybody with me? So, yes. Okay, yeah, I'll explain that right now. So, with that said, right now we're going to go ahead and cover both, but I need you guys to write down some steps. Here we go. Steps 1 through 3. Copy these down. Step 1, organize information in a table. Step 2, identify the pattern. Step 3, define if arithmetic or geometric. Organize information in the table, identify the pattern, define if arithmetic or geometric. Organize information in the table, identify the pattern, define if arithmetic or geometric. Now, most of the examples are not going to ask you to write it in the table. I just wrote this first step so that if you want to get organized, it's a good way of doing it by writing a table. But usually we can find the pattern and define it, whether it's arithmetic or geometric, by a couple of things that I'm going to show you. Okay? So, 3 easy steps. Everybody got it? So once again, organize information on the table, identify the pattern, define if it's arithmetic or geometric. Okay, write example 1A, 1A. Copy the text, please. Oh, sorry. Before we move on, copy this down, please. Oh, sorry. Copy this down. And let me show you what you need to copy. Don't copy this text. Don't copy that text. And the reason I don't want you to copy it because it's kind of confusing. I'm just going to label stuff. However, do title this formula when finding the nth term of an arithmetic sequence, and this one when finding the nth term of a geometric sequence. In the green, this one is A with a little sub 1 in it. Copy that, please. All right, write this down. I'm going to break down each piece in green for those of you that have colored pens. In green is this part right here. It says A sub 1. And I'm going to write, oh, wow. A sub 1 is the first number in a sequence. First number in a sequence. So I'm going to point to this one, and I'm going to point to this one. That's where it goes. So for example, if I was to say 1, 3, 5, 7, what is my first number in that sequence? So where would that go? Right there where it says A sub 1, the number 1 goes there. Everybody with me? Next, right here we're going to write pattern. Pattern. And you're going to point to the letter D and to the letter R. Most sequences are going to have a certain pattern, and you can follow the pattern going from one number to the other. That number is going to go for this one on the D, for this one on the R. Okay? Okay? And the last piece of information, I'm going to write it in red right here. The missing term. the missing term. We're going to point to the letter N, to the letter N, to the letter N, and to the letter N. And what am I talking about that? When I give you a certain sequence of numbers, I'm going to ask you, find the 10th term, the 10th number, for say, from the sequence. That's the number that we're going to be looking for. That goes there. Okay? That's the number of the term. And I'll show you what that means. Okay? So first and foremost, we're going to start, I want you to see first what an arithmetic sequence is. Okay? So let's write that down. Example number 1. Copy this down, please. For this one only, you're going to write the black text. For the following, you won't. So just write example 1A. Determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference and the next 3 terms. If you see the pattern, don't say it out loud. Keep it to yourself. Let people think. Once again, write this down. Determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference and the next 3 terms. And the sequence of numbers that they give us is 9, 13, 17, 21. Copy that, please. Pens down, eyes up here. Here it goes. It says, focus please. Determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference and the next 3 terms. So pens down, eyes up here. Like I said, when I give you a sequence of numbers, they usually have a pattern. Let's see. Don't say it out loud. From here to here, something happens. From here to here, something happens. And from here to here, something happens. And it looks to be it's the same thing that's happening for each one of those. Who sees that they're adding 4, 4, and 4? This is known as the common difference. Common difference. Are we there? Now, check this out. The letter D for difference is the letter that we're going to use, and we write D equals 4. That's our common difference. Why do I need to write it like that? Look at our formula. What was our formula? Didn't it have a little d right here? That's where we're going to substitute that number once we use the formula. Does everybody see that? Okay? So therefore, now that we have found this, it says, if so, find the common difference. There it is. And the next 3 terms. So with the same pattern, let's see. Volunteers, what would be our next number? Yes. 25. And the next one? No. Yes? Haley? 29. Very good. And Paul? 33. Hands if you saw that. Okay? Copy that, please, and then we'll move on to the next one. Okay, so as you're finishing copying this, here it goes. This is a sequence of numbers. Does everybody agree with that? Yes. It has a pattern. This pattern is called the common difference, and we'll use the letter D because we're going to use this when we substitute into the formula in a little bit. And each one of these numbers is known as a term. How many terms did they give us in this sequence? 4, and they told us to find the next 3 terms. Everybody with me? All right, so now that we have our vocab done, let's go to the next one. Example 1B. Do this one by yourself. You don't have to copy the text, just copy the sequence. Here it goes. Copy that sequence. 10, 8, 5, 1. And then the information is the same. Determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference and the next 3 terms. Let's do this one together. Here we go. From here to here, what happens? Minus 2. From here to here. From here to here. Minus 4. So, let me ask you a question. Look at this one. Wasn't this one the same number for all 3? That's why it was an arithmetic sequence. So therefore, since this one does not have the same number for all three, this is not an arithmetic sequence. And we're done. We don't have to find the next three numbers in the pattern.
Is this not an sequence?
Yeah, that's fine. Everybody get it? So when there's a pattern, it is a sequence, an arithmetic sequence, but if it doesn't have it, then it's not. All right, let's move on to the next one. Here we go. Example 1C. I'm sorry, 2A. Example 2A. Copy the text, please. It says, find the indicated term of the arithmetic sequence, and then you're going to write 60th term, colon, 11, comma, 5, comma, -1, comma, -7, comma, and then we need to figure out the rest. Copy that, and then I'll go over this one. Okay, here we go. Pens down, eyes up here. So notice this one has a little bit of different information, but we still have a sequence, don't we?
Yeah.
So let's find, first of all, the pattern, our common difference. Let's see, from here to here, from here to here, and from here to here, it looks like from here to here they subtract 6. From here to here they subtract 6. And from here to here they subtract 6. Is it the same number for all three? Yes, so therefore this is an arithmetic sequence, and our common difference, we use the letter D, is what? -6. Are we there so far? Okay. The only difference on this one, they don't ask us for the next three numbers. They ask us for the 60th term. This one they give us 4 terms, and the previous one we found the 3 terms that we're following. But this one they want us to find the 60th term, which is way over here. So how do we do that? Here it goes. We use our formula that we wrote down. A to the sub n equals A to the sub 1 plus parentheses n minus 1 times D. So check this out. First of all, do we know the value of D? Yes, so instead of D, we're going to substitute the number -6. Open parentheses for this one, minus 1. Okay, hold on. So now, I heard some of you say A1, this is the very first. No, I heard somebody over there too. A1 is the first term of our sequence. What is our first term? 11. So that one goes and substitutes in there. So far so good? And it says sub 1 because this is letting you know that it's the first term. Okay? And which term are they asking us to find? The 60th. And that's going to replace the letter N. So this is A sub 60 equals 60 minus 1 times -6. And once we have this, we can simplify this to find our number, but we need to use order of operations. Please excuse my dear Aunt Susan. No, I don't have Sally. All right, here we go. So, parentheses. We're going to start with a parentheses. Can we simplify this one? 60 minus 1, that's 59. And we need to multiply times -6. And then at the end, we add 11. And that's going to give us our 60th term. So let's see. We're going to continue with our order operations. No exponent. Multiplication and division. Yes, right here. So 59 times -6. That's 54. We got 5. 35. And this is a negative. So this becomes -354. And I bring down the 11. And this is A to the 60th. So A to the sub 60 is -340 3. That would be my 60th term over here, negative 343. How we doing? Not bad, right? So pretty much on this one, all we have to do is write our formula. We need to find our common difference and just substitute values to find our whatever term that they're asking us for. Yes? Okay, here we go. So that was 2A. Copy this one and see if you can do this one by yourself. Example 2B. 2B. It says, find the indicated term of the arithmetic sequence, the 16th term, and the sequence that they give us is 4, 8, 12, 16, and they want us to find the 16th term. Yeah, you don't have to write this first part, just write 16th term, colon, 4, 8, 12, 16. See if you can find it, please. Go. 4. So let's see. 16th term. Let's see. First, we need to find our pattern from here to here, here to here, here to here. This becomes plus 4, plus 4, plus 4. So our D equals 4. Are we there so far? We find our formula. A sub n equals A sub 1 plus parentheses n minus 1 times D. This becomes A sub 16 equals 4 plus 16 minus 1 times 4. Yes? The term that they want us to find. So here we go. So A sub 16 equals, this becomes 4 plus 15 times 4. What is 15 times 4? 60 plus 4 equals A sub 16 is 64. All right? So check this out, guys. Everybody look up. Pens down really quick. So we just covered arithmetic sequences. Check this out. So what can we conclude? If it has a common pattern that they add or subtract the same number, that's known as a common difference, it is an arithmetic sequence. We have a formula that they give us in order to find a certain term that they ask us for. Are we there? So if for arithmetic sequences we found that it's subtracting or adding, think about it and don't say it out loud. What do you think is going to happen for geometric sequences? If for arithmetic sequences we subtract or add for the pattern, what would we do for geometric? Tell your neighbor, please. Okay? So yes, I heard multiply and divide. So let's get into geometric. Here we go. Copy this next one, please. Example 3A. It says, find the next 3 terms in geometric sequence. Find the next 3 terms. Yes, write this down. Find the next 3 terms in the geometric sequence. 1, 4, 16, 64, da, da, da. See if you can do that one by yourself. And remember, now we are in geometric sequences, which means we're either multiplying or dividing. Okay, go. So, let's see. From here to here, something happens. From here to here, and from here to here. Who saw that it multiplies times 4, and times 4? That's our pattern. But for arithmetic sequence, it was the letter D. For geometric sequence, it's the letter R. And this is, the letter R is 4. Why the letter R? Because this is known as the common ratio. Common ratio. Where did they get the R from? Ratio. Are we there? And they ask us to find the next 3 terms. So what would be the next one here? 256. And the next one from there? 1024. And the last one? 4096. Hands if you got that? Okay. So far, notice that we got that step down, right? Let's do another one. Here we go. Copy the next one down. Example 3B. You don't have to copy the instructions. Just make sure you copy the sequence. Copy this one. I know. Here we go. Example 3B. It says, find the next three terms in the geometric sequence. Once again, don't write the information down. Just write the sequence. -9, comma 3, comma -1, comma 1/3, comma -1/9, dot, dot, dot. And they want us to find the next three terms. All right. Everybody look up, please. Hint, from this point forward, when we are looking at geometric sequences, everybody look up. Who noticed in this sequence here that they gave us one of them is negative, the next one is positive, the other one is negative, the next one is positive, the other one is negative. Whenever you have the alternating symbols, your common ratio is always a negative. Are we there so far? So with that said, do we multiply the 9 or do we divide the 9 to get 3? Divide. So therefore, we divide by -3. Is that correct? What is -9 divided by -3? +3. Let's see if the same pattern works for this one. +3 divided by -3. What is that? -1. -1 divided by -3, that's +1/3. 1/3 divided by -3 should give us -1/9. How did they get that? 1/3 divided by -3. This is 1/3 times 1/3, which becomes 1/9, and it's a negative. Everybody with me so far? So now, if you find the pattern being a division, our ratio is -3. -3. They're dividing. Another way of writing this in multiplication, if it's a division, we can write it as -1/3. Does everybody see that? What if the common ratio was -5? How can we write it as multiplication if over here it's dividing? -1/5. Did you understand that? I'm making this up. What if the common ratio was a 7? What would be our multiplication if there was division? If this was dividing, this is times 1/7. Everybody there? All right. So now that we have that done, now let's get into using the formula. Copy this next one down, please. Oh, the next three numbers, let's see. We got 1/9 times, divided by -3. So what is negative times a negative? Positive. 1/3 times 1/9 is 1/27. The next one, -1/81, comma, and the next one positive 243. Okay? Copy this next one down, please. Copy that one for A. Copy the black text only. It says, the first term of the geometric sequence is 500, and the common ratio is 0.2. What is the seventh term of the sequence? The first term of the geometric sequence is 500, and the common ratio is 0.2. What is the seventh term of the sequence? Now, once again, this is going to be similar to the one we did with the arithmetic sequence. But on this one, they actually already give us all the information. Do they give us the first term? Yes, it's 500. Do they give us the common ratio? Yes, it's 0.2. Do they give us which term to find? Yes. So for this one, check this out. We write our formula for geometric sequence. A sub n equals the first term, which is A sub 1, times the common ratio, which is R, and R has an exponent of n minus 1. Okay, so let's see. What's our first term? Do they give us the first term? First term of the sequence is 500. So instead of A sub 1, we're going to write 500. Times. because that's what the R next to it means. Times. What is our common ratio? 0.2. Are we there so far? Okay. And which number of term are they asking us to find? 7. So therefore that goes here, and that goes 7 minus 1. So let's see. Let's simplify this. This becomes a sub 7 equals 500 times 0.2 to the 6th power. It's a 7, yeah. Do we know what to do from here? We need to do the power first. So this becomes, this says 0.2 times itself how many times? 6. So check this out. Careful with these. Everybody look up. 0.2 times 0.2 becomes 4, but there's 2 decimal places. So 1, 2, and we add a 0. We multiply again times 0.2. 2 times 4, that's 8. 2 times 0 is 0. How many decimal places? 1, 2, 3. So 1, 2, 3, 0.008. And again, times 0.2. How many times are we going to do that? 6. And then at the end, you just multiply times 500. That's how you find your 7th term. Homework. Pages, what was the first one? 237. And the other one is page 735. Each one of those numbers 1 through 23 odd only. Both of them. Enjoy your homework, everyone. Have a good one. I'll see you guys tomorrow. Yes.